Hey guys, so in this video we are going to talk about OpenClaw project built by Peter Steinberg, and this is going to be my take on it. We'll go through the project at a higher level, especially the architecture, because I've noticed that a lot of people using the project don't really understand what's actually happening behind the scene. They use it, but they don't really understand the product. Now, apart from that, we'll also talk about how builders, founders, and even tech undergrads can actually use OpenClaw in their day to day work. Over here, I would like to highlight one more thing. A lot of people think OpenClaw is built for everyone, including the non techs. So, I've been experimenting with it for the past week, and based on what I have learned, that's not entirely true. But if you guys think you can keep up with the video, that's great. Even some tech knowledge will work. So, to get meaningful results, you do have to change and configure a lot of files. So, you need to understand what you are doing to make it actually useful in your daily workflow. But, I'll try to explain it in the easiest way. Now, some people have built one click tools on top of it for non-tech users, but I haven't personally used those, so I won't comment on how well they work. Now, finally, I'll show you how to set up a multi-agent system, which I found to be one of the best approaches in terms of cost, token usage, and clear task division in a multi-agent architecture. So let's get started. Okay, so now before we even get into the architecture, it's important to answer why we should study it in the first place. The reason is very simple. When you understand what's happening under the hood, you become a much better judge of the system itself, its capabilities, its limitations, and most importantly, what's it actually good at and bad at. Without that understanding, it's very easy to either overhype it or completely misjudge it. So, first thing, OpenClaw is not a personal assistant, it's not an AI agent, and it's definitely not a chatbot. OpenClaw is an agent runtime that you can install on your local machine along with a control layer, or you can run it by connecting model APIs. Now, at its core, OpenClaw uh, is mostly built on TypeScript, right? So, what happens is OpenClaw runs on your machine and exposes a gateway server. This gateway is responsible for handling all the incoming connections, whether that's Telegram, WhatsApp, its own web UI or CLI, or even a remote access from another machine. On top of that, it make calls to different LLM APIs. So if we come to the official doc, search for providers. So these are all the LLM providers that you can call with the help of OpenClaw. And then it executes the tools locally on your system. So think of it as an infrastructure that connects messages, models, memory, and tools into one runtime. Okay, so let's understand the architecture with the help of this diagram. So here's what actually happens when a user sends a message to OpenClaw through any message provider. It can be Telegram, WhatsApp, or through OpenClaw's own CLI or web UI. The first thing, user message hits the channel adapter. Now, the responsibility of channel adapter is normalization. So, messages coming from any channel provider are always platform specific. Let me give you an example. So, this is how a message coming from Telegram from the user will look like. It might have message ID, text, some attachments, and other user metadata. Now, this is not useful for OpenClaw as the system does not understand any of this. So, the work of channel adapter is to normalize this message into something that the OpenClaw system can understand regardless of where it is coming from. So after the channel adapter has done its magic, it will have some fields like user ID, session ID, tag, maybe the data coming from the PDF will be extracted in Word format. The images and the videos will be converted into something like blob. That is something that the OpenClaw system will be able to recognize and will be able to work with it. Okay. Now, before the message moves further into the system, there is an important onboarding choice that you'll have to make as a user when you are setting up OpenClaw. Now, when you set up OpenClaw, you essentially have two modes of operation. You can run it locally by default, where it becomes a WebSocket server bound to localhost loopback, meaning the system cannot be accessible by anyone outside your machine. So that is the first mode of operation. The second one is you can expose it remotely using SSH tunnels or Tailscale. So Tailscale deserves its own deep dive, but at a higher level, Tailscale is a matched VPN. Let me show you guys. On the left, you can see this is a traditional VPN architecture where the server and the clients are connected with a centralized entity. While on the right, you can see how Tailscale architecture works. So you can think of it as a device to device mesh network. Now, the advantage of Tailscale is it can allow secure access without exposing the system publicly. You can read more about it on the Tailscale official docs and about the product, and you'll get the gist of it. Now, once the message is normalized using channel adapter, it moves into step 2, the gateway server, which has two major responsibility. The first is session router. This component decides which session the message belongs to, which agent instance should handle it, whether there is already an active session running or whether a brand new session needs to be created. This is what gives OpenClaw continuity instead of treating every message as a fresh request. The second responsibility of the gateway is handling the lane queue system. Each session gets its own queue, and by default, it follows a first come, first serve scheduling algorithm. I think something you've already probably encountered back in college when learning about scheduling algorithms. Now, since OpenClaw is built using TypeScript and runs on Node.js, which is single threaded, you cannot afford to get stuck in async await loops. And the lane queue system ensures that. Even if multiple messages arrive at the same time, tool calls are running or several sessions are active in parallel, nothing blocks the system. Now let's understand it with the help of an example and a diagram. So here it is, the incoming message which was normalized by the channel adapter. Then it goes to the session router, which decides which session the message belongs to and to which agent the request should go to. Now, let's say there are three parallel sessions going on: session 1, session 2, session 3. Each session has their own lanes. Session 1 has three processes A, B, and C. Session 2 has two processes D and E, and session 3 has two processes F and G. Now, for session 1, the first process that comes into the lane is A. It runs and gets executed. Then comes B, it runs and gets executed, and C, which also gets executed. While in session 2, the process D is still waiting for the IO approval. Now, with this, we can understand that while one session waits, other sessions continue executing. This ensures messages are processed in order, sessions don't interfere with each other, and system runs smoothly under load. Now, when a message clears the gateway, it reaches step 3, which is the agent runner. The first thing that happens here is model resolution, which is done by model resolver. The system determines which model was selected by the user during onboarding and which model is configured for that particular agent. As in a multi-agent setup, different agents can use different providers and can have different API keys. So all of this is resolved from the authentication configuration, which stores your environment variables as well. Now, next come the system prompt builder. As the name suggests, it compiles everything the agent needs into a full LLM context. This includes the available tools, the agent skills, and workspace files that are stored locally. These workspace files effectively define the agent's identity, and as you continue interacting with the agent, these files can evolve and get updated over the time. After that, we have session history loader. So the loader pulls in the conversation history so the agent has full context. When searching for a relevant memory, the agent does not just scan text. Past conversations are broken into chunks and stored in SQLite using two indexing methods. Now let's discuss those indexing methods in detail. So basically, OpenClaw maintains two files, memory.empty file, which is a part of agent workspace. It is a special kind of file that only stores key conversation blocks between the user and agent that can be used in future references. While session.jsonl file, it stores the entire conversation between the user and the LLM for that entire chat session. Now, these two files are broken in data chunks and stored for agent lookup using keyword and semantic indexing. Let's talk about indexing first. So, keyword indexing stores each conversation chunk using SQLite full text search framework. Behind the scenes, SQLite builds a word to document map and inverted index, which is the same code data structure used by search engines. Now, let's take an example. If the user asks agent, what is the capital of India? And the data chunk stored in the local DB is something like the capital keyword is occurring in doc 3, doc 17, and doc 9 respectively. And the keyword Delhi is occurring in doc 3, doc 8, and India is occurring in doc 9. Now the system immediately retrieves the chunk that directly matches those keywords. This provides fast and precise recall with almost zero overhead. Now, the second indexing that OpenClaw uses is semantic or vector based indexing. Now, consider a more complex query like what is the capital of India as of 2026? Tell me now. Now, in this case, exact keyword matching alone isn't sufficient. So, the same conversation chunks are also stored as vector embedding inside SQLite blobs. So chunks are combined and their respective locations are stored. So for the sentence, what is the capital of India? Capital Delhi, and the vector location is stored 10, 20 of India 11, 19 and Delhi, India 200, 400. These embeddings capture semantic meaning rather than just literal words. Comparisons here use cosine similarity or dot product, effectively measuring the angle between vectors. The smaller the angle, the closer the meaning. This allows the agent to retrieve relevant context even when the phrasing doesn't exactly match the past conversations. Now, finally, the result from both vector and keyword indexing is merged through hybrid retrieval. Uh, this hybrid approach compiles the final memory context that agent uses to respond. So at this point, it should be clear that this is no longer behaving like a simple chatbot. There are complex systems in place that makes OpenClaw one of a kind. Okay, so again, we come back to agent runner. We have discussed model resolver, its purpose, system prompt builder, its purpose, and session history loader. Now, basically, the LLM context will be created from these two combined. This context eventually passes to context window guard. Now, what context window guard does is if there is enough space in the context window, everything proceeds normally. But if the context is close to full, the session is compacted, usually by summarizing, or the system fails gracefully instead of crashing. Okay. Then comes step 4, the LLM API call. Now, the LLM provider is chosen by you while doing the onboarding setup. This is where the actual model invocation happens. Now, here the model may stream responses token by token, request extended reasoning if supported, and return either a final text response, a tool call instruction, or maybe even both, depending upon the message or prompt given by the user to the agent. Now, after that, system directly moves into step 5, the agent loop and tool execution. So, the agent loop begins as the model response. If the response contains a tool call, the system executes the tool via OMyPy RPC. Let me show you. So this is an open source project. Now, what is RPC? So RPC stands for Remote Procedure Call. It was developed in the late 90s, 70s, between early 90s, 80s. The new high term that you hear nowadays, the MCP, it is nothing but a new take on RPC only. Now, what OMyPy is, it's an AI agent toolkit with the RPC mode on. OMyPy enables headless operations of the coding agent via JSON protocol. This is how OpenClaw agents can access and manage your applications, IDEs, CLI, or browser search. So now the final captured result feed it's back into the model and repeats the loop. If there is no tool call, the response is treated as final and the loop exits. The cycle continues until a final answer is produced, maximum step limit is reached, or an error occurs. Uh, all of this is governed by tool access control, like which tools the agent is allowed to use and which one it isn't. Here the arrow is wrong. Sorry for that, guys. It should be pointing over here, not here. So sorry for that. So once the final output is ready, it moves back through the response part to the user. The response can be streamed token by token or sent as a single message. Now the outgoing channel adapter then converts the internal response format back to initially whichever the message provider user chose to send the message. Now, after working with the project for more than 1 week and studying the architecture, one area that still clearly needs improvement that I thought is tool calling and tool gatekeeping. So during the initial setup, many tools are exposed by default and the system still has to reason about. So whether an agent actually has access to them. So in that scenario, tighter controls and clearer boundaries have to be set to make the architecture even stronger. Now with that foundation in place, we move on to the multi-agent setup guide. Hey guys, so because I have already installed OpenClaw on this machine, so we'll just remove the existing configs and the agent context from this machine and start with a clean setup. For that, I'll just need to run OpenClaw uninstall command. From here, we just want to keep the gateway service. Apart from that, everything else goes. Okay, now to start the OpenClaw wizard, we run OpenClaw on boot command. Yes, we'll start with the manual setup. Now, these are the two operations that we discussed during when we were going through the architecture as well. So here OpenClaw is asking me that whether you want to configure me on this machine or you have uh, a separate machine where I'm already running and you want to open a remote SSH tunnel to that device. So we just want to run you on this machine. Then we choose the LLM provider. I'm going with Open Router. Let's choose the model, Flash. Loop back. Let's configure the message provider. We'll choose Telegram. Telegram bot token. So I have pushed my bot token. Let's finish pairing. No, no. Do this later. Now, this is the bot that I already have configured on Telegram. Let's put start. Now, let's put this. So you can see this is the pairing which is still pending. So we'll run OpenClaw pairing approve and the pairing code. Right. So now if I send a message from Telegram, I think my agent will be, yeah, so it is typing. So guys, with this, OpenClaw is running on your local machine and you have configured Telegram and connected OpenClaw with Telegram. Now, if I ask my agent, hey, how are you today? Right, so I am getting replies from the agent. So guys, when you successfully configure OpenClaw, OpenClaw creates a .openclaw folder in your root directory. Now, this folder contains all of the config file as well as the agent context file that OpenClaw needs. Now, next we are going to go into the .openclaw directory and learn a little bit about this workspace. Okay, so guys, let's dive in. Now, you don't need to know everything here. We'll just focus on three things: the agents folder, the workspace folder, and the global config file, which is openclaw.json. Let's start with the agents directory. The first important file here is authprofiles.json. You can think of this as the LLM provider config file for your agent. As you can see, it contains the information about the LLM provider the agent is allowed to use and the API key for that provider. Next, we have session files. The first one is session.json. This can be treated as the summary file. The system uses it to understand how the session should be resolved. It contains the information about the message provider, the tools that are available to your agent by default, and the part 2, the agent's workspace file, and few other agent level configuration fields. Then we have the JSON-L file. This file contains the raw logs of every message exchange between you and your agent for that particular session. Over time, this file can grow quite large since it stores a full conversation history. Now, let's move to the workspace directory. This directory represents the identity of your agent. The agents.md file is loaded every time a new session starts. Now, if we open it, you'll see that it guides the agent through this directory, basically telling it which files exist here and when each file should be used. The next we have identity.md file. This works like a identity card for your agent. So it defines the agent name, its overall vibe, and small things like whether it can use emojis or not. Then we have user.md file. So this file tells the agent who you are, what kind of work you do, and what you usually want help with. Now then we have the most important file in the workspace, soul.md. So this is where the agent's personality lives. It defines how the agent thinks, how it behaves, what skills it can use, and when should it use those skills. Okay, so now finally we have the global config file, openclaw.json. So this file is resolved at the gateway level. It defines routing, default agent settings, primary and fallback models, and message providers. So, if you ever want to make any system level changes in OpenClaw, whether that's LLM calls, tool calls, message routing, or session binding, everything sits inside this file. So that's the code layout. Once you understand this structure, navigating and configuring OpenClaw becomes much easier. Okay guys, so now let's move from a single agent setup to a multi-agent setup. To do that, you really only need one command: OpenClaw agents add and then the agent's name. So when you run this command, OpenClaw automatically creates a separate agent session directory and a separate workspace directory for that new agent. Now, every agent runs in its own directory with its own files. Agents are not self-aware of each other by default. They don't know other agent exists unless you explicitly connect them. This is a default behavior of OpenClaw multi-agent routing. So think of it like everyone has their own personality, their own memory, and their own way of thinking. But in our case, we can make the main agent aware that our other agent exists and even let it read from their workspace if we want. Now, instead of manually setting up everything from a new agent, I am going to spawn one using a framework that I have built called Castroom. So, Castroom automatically injects personality content into the agent workspace, so you don't have to spend hours writing prompts or training the agent from scratch. Agent still has full freedom to evolve. You can overwrite its roles, guide it over time, and shape its behavior as you interact with it. So now I'm going to configure Michael as he is my favorite character from the office. Now I can directly run the command. Yes, I want to create a separate workspace. Sure. Copy auth. No. Configure chat channels. No. Okay, guys. So done. Now, if we open our workspace, we can see that OpenClaw has created a separate workspace for Michael as well as a separate agents session directory for Michael as well. Now to properly configure Michael, so we can send messages to him directly from Telegram. We need to make a few changes in openclaw.json file. Also, if you notice that identity.md file in the case of Michael is already populated compared to identity.md file of our main agent. That is because of the Castroom framework that we used. Now in OpenClaw file, first we'll add the modified channel object and binding object to properly configure our agent channel binding. So here we go. Here we have added the bindings to properly map our agent with our Telegram channel. And here I have already added my previous bot token and token for our Michael agent as well. Okay, so now if you want, you can also add a tool allow list object inside your agent list object for your particular agent. So this part is optional as your agent has a read access of the file system by default. I'll this for both of them. Now we'll finally add some context data in our main agent soul.md file uh, so he can access Michael's workspace. So now this context you can add according to your needs and modify it further as well. Now once these changes are done, we'll stop the gateway and start it again. So for that we'll use the command openclaw gateway stop. and then we'll write OpenClaw gateway. Now, if you look at the logs, you can see that the agent binding is resolved properly. Okay, so now we are going to try to send message to Michael. Okay, so Michael is active with his context. Now let's open our main bot and tell it to reload its soul.md file and check if he has the access or context of who Michael is. So he has the context of Michael. Okay, so with this, guys, you have successfully configured a multi-agent system. Now, this was just an example. You can play around and create something even complex with this knowledge. You have noticed by now that this is a pretty advanced OpenClaw setup. I haven't really seen many people using it this way. Most setups stick to a single main agent, and if things get too complex, they spin up a sub agent. But this architecture is different. Here you can properly couple and decouple multiple agents. Each agent can stand on its own. You can still create sub agents for them, and if you want, you can even share knowledge or memory across these agents. That gives you a lot more flexibility and control compared to the usual single agent approach. Now let's talk about some use cases. Your agents already have CLI access and browser search access by default, so you can easily create a builder agent for your side projects. You can give it a to-do list or a prototype plan and let it help you build a MVP. You can create a personal assistant agent that reads your emails or Microsoft Team messages and helps you plan your day. You can have a workout agent that designs your training and diet based on your daily metrics. Or you can mix all of this together and build a system where different agents handle different parts of your life. With this setup, you are not limited to one role or one workflow. You can create as many agents as you want, each with a clear purpose. And honestly, once you reach this point, the sky is really the limit. So, on that note, we'll wrap this up. Thanks for watching, and I'll catch you in the next one.